I'm your host, John Myers, live from Stillwater, Oklahoma. We have got a great show tonight. It's John Myers. Hey, everybody. Gotta have my notes. It's John Myers from the Kicker UnMasked studios. Gotta have my notes. Alternator. Hey, everybody. We have fun. Hey, everybody. Hit like and subscribe. Right here, right now. It's John Myers. We like to give stuff away. Alternator. Post some more pictures. We got to thank Steve and Becky live from Stillwater, Oklahoma. Don't forget Texas Roadhouse right here, right now. Hey, everybody. Don't forget right here, right now. We have got a great show tonight. Hey, everybody. Had a great dinner tonight. It's John Myers. Right here, right now. Had a great dinner tonight. So, hey, everybody. So, housekeeping. Had a great dinner tonight. So, alternator. Housekeeping. Housekeeping. So, Tuesday night. Housekeeping. From the Kicker UnMasked studios. Housekeeping. Right here, right now. Hey, everybody. So, it's John Myers. Hey, everybody. It's John Myers from the Kicker UnMasked studios. Hey, everybody. From the Kicker UnMasked studios. It's John Myers. Right here, right now. We have got a great show tonight. Hey, everybody. We have got a great show tonight. It's John Myers. Hey, everybody. Right here. Hey, everybody, it is Tuesday night, Unmasked Live, coming to you from Stillwater, Oklahoma, where it is dark, foggy, rainy, misty, kind of like my own attitude. But anyway, hope it's nice where you guys are at. It's been kind of crazy around here with the weather. As usual, we had a great dinner tonight. I'm sure you guys want to hear how awesome Texas Roadhouse was. They really need to give us something for all these plugs, I think, anyway. If you guys watched the last show we had a really good show talking about Skills USA. If you guys are unfamiliar with Skills USA, it's a competition put on around the country where people learn all kinds of trades and they're tested on them by various industry professionals, not unlike ourselves here. Jacob and I have had some fun making some displays for these guys to take around the country and compete with. So we've taken a real active part and helped further the knowledge of this whole cardio industry, which is one of the reasons why we're here tonight, and hopefully to have some fun and learn a little bit more. So I've got a special guest coming up here in a little bit. We've a great show, but if this is your first time signing in, don't forget to hit the like and subscribe button. The more you guys like us, the more you subscribe, the more we get to do this. Also, if you're new to the show, we give away something on every single show. So if you get online and type in kicker.com/UMweekly, you can register tonight to win one of 3 groups of prizes. The third prize winner is going to get the green Kicker tumbler, a Kicker koozie, and a Kicker Unmasked t-shirt. Second prize is going to get, I'm almost forgetting here. If you pull that up here, Ernie. Second prize is going to get the EB400, the wireless earbuds, the koozie, and the t-shirt. And the grand prize winner is going to get the BF100. Is that right? Yep, the BF100. I got to make sure. It's been a while since I've done this, guys. I've been slacking. I've been all over the place, but not here. So, guys, make sure you register, hit like and subscribe. If you guys have any questions, be sure to type them into the chat box. Bill is going to record all of the questions. If we don't get your questions tonight, we will answer you via email or some other method of Bill's choosing. He's got that all figured out, I'm sure. more than I do anyway. So the other place you can get answers is support@kicker.com. And if you want to send questions to Bill, that's social@kicker.com. So make sure you guys send your questions. We will get to your answers. And make sure that you guys remember that tonight's show is going to be very interesting. We're not here to tell you everything there is to know about magnetism, because I'll be honest, the more I researched it, the more I realized there's a whole lot of information out there, and a lot of it's good, a lot of it's bad. But we just want to basically get you guys start thinking about it and dispel some of the rumors that are going on about, you know, what's good, what's bad in magnets, and let you guys make up your own mind and do a little research, because this is a very deep subject and we're only going to touch the surface of it. So I'll do my best to answer questions, but I promise you, everybody's got their own opinions. Not everything everyone says is going to be agreed upon by everyone, but we're going to do the best we can and have some fun. And what an attractive subject that is. So let's take a quick little break and we'll be right back at Kicker Unmasked Live here on the Kicker YouTube and Facebook channel.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
Music is my passion, my livelihood, and it's in my DNA. My pals at Kicker Marine Audio gave me a chance to take the music, what I love and listen to, at home, on stage, and in the car, onto the water. Hi, this is Jason Bonham, and I want to say a big thank you to my friends at Kicker Audio for inspiring the songs and the stories behind the music that inspires America. Go overboard! This is your time.
Something bad, your hands on the wheel, got a sexy touch. It's enough to make me and my Chevy blush so long. Take it all off of that highway, turn me on, I'll let you drive, babe. You can take it fast as you want to. Turn a little dirty, looks damn good on you. Start me up, Stones on the radio. Girl, I love it when you let go. Don't waste your way in the wrong way. Get off on some 4x4 play.
We are talking magnetism tonight. What makes a good speaker, bad speaker? What's the differences in the magnets, the types, the styles, the configurations? We're going to go over a whole bunch of things, and like I say, this is just like a 10,000-foot overview of what really goes on with magnets. I'm not an engineer, I don't claim to be, and after reading what I was reading about magnets over the past 2 weeks or so, I don't think I want to know any more than I do, but it's a very, very interesting subject, and if you guys really like to go down that path, dig into it, do some research, kind of make up your own opinions. But we want to go over, the basics of magnets, what they are. And first of all, why do we need magnets? I mean, what is a magnet? What does it do? Well, a magnet basically is a material that attracts ferrous materials like metal, steel to be, cast iron. Anything that can be magnetized is a ferrous material. So non-ferrous means it can't be magnetized. So that's the difference between ferrous and non-ferrous. But when it comes to magnets, the reason we need magnets is the speaker has to move. It has to have an outward motion and an inward motion. Well, a speaker needs something to push off of. So you've got a coil of wire inside the speaker called the voice coil, which we got kind of a cutaway of a speaker over here. We'll show you closer in that just in a few minutes. But the coil of wire, as you pass energy through any wire, it develops a magnetic field around it. Well, that magnetic field is stationary as long as the current and the direction of the electric flow is the same. So the more power you run through a wire, the bigger and stronger the magnetic field. But you get to a certain point where you can no longer pass any more current through the wire, and it's actually going to break down, and then you have a burnt voice coil. That's kind of one of the things that happens with overpowering speakers. So you need a stationary force for that magnetic field to be pushing against or pulling against. And that's what the stationary magnets in the speaker That's what they do. So they allow that speaker to push and pull, and we use AC, or, alternating current, because in one direction you pass current through, it's going to push the speaker. You turn around, go the other direction, it's going to pull the speaker. And you vary that at, a high frequency, and the frequencies that you vary that, being, how many times a second it varies, is called hertz. So 20 hertz means that speaker is going to change directions 40 times a second, which 40 times at 20 hertz, that means it's going to go up, it's going to change directions again, go back, and change directions again. So even though a speaker is playing 20 hertz, it's actually changing directions 40 times a second. And that's what those magnets allow you to do. The more powerful the magnet, the better the whole geometry of the speaker, the better it's going to work, the more it's going to work, and the more powerful it's going to be. Now, one of the big misconceptions about speakers and magnets is the bigger, the better. You put the biggest, baddest magnet on a speaker, you're going to have a better speaker than the one with a smaller one. Well, I've got an example in front of me right here. I've got one of our Power Sports speakers, and I've got one of our KS series speakers. And if you look at those two speakers carefully, obviously the Power Sports speaker's got a much smaller magnet structure than the KS series. So that means the KS speaker is much better, right? Not necessarily. It depends on the type of material. The other thing we need to consider is magnet is part of a circuit. It's called a magnetic circuit. You have to have a good circuit. All the components must be there. They must be balanced. So the little speaker here on my left, which I think is on your right, the Power Sports speaker, that uses something called a neodymium magnet. Now there's several different types of materials. You have ferrite, you have cobalt, and those are forms of ceramic magnets. Then you get into El Nino magnets, which are not really used in audio. They're great to be used in a couple areas such as guitar pickups, electric motors, very small, concentrated, very powerful magnets. But once again, with the advent of some of the new technologies, they've really migrated away from, really common everyday use, and that's where we're going to see a lot of the ceramic magnets and a lot of the neo magnets are taking over. Now, there's good things and bad things about all magnets. Now, obviously, the ceramic magnets are going to be the most popular. Now, I'm going to tell you a couple fun stories, that have happened over the years. I was actually in a hallway waiting to go to a training. There was another vendor there, and we won't tell you who it is, but and you probably won't even be able to figure this out unless you've heard me tell this story before. But we always put boots on our magnets. So if you look at the back of this awesome half woofer, you've got a boot on the back of the magnet. Well, why do we put the boot on the back of the magnet? Is it just to make it look bigger? No, not at all. Is it to improve the performance? It doesn't even improve the performance of the speaker. But what the boot does, it does have two very, very important functions. The first one is it looks cooler. It looks nicer, because bare magnets are just kind of ugly and blah. They don't really look exciting, so we want to make sure the speakers look presentable, especially if you're going to flip them over and show the back sides of them. So that's the main thing that we use the magnet boot for. The other thing, which is kind of, one of those little subjects that people don't even think about, that magnet boot will protect that speaker. As we mentioned, the ceramic materials, ferrite, ceramic, cobalt, samarium, all those are a form of ceramic material, and we know from coffee mugs, if you drop a coffee mug on concrete, it's going to shatter. Same thing happens with the ferrite magnets. They can break, they can shatter, they can chip, so that magnet boot helps that magnet, in case you happen to bump it on a hard surface, it doesn't shatter or break the magnet or chip pieces off of it. A few pieces aren't going to affect it, but if you break big chunks of it off or break it in half, the magnet's pretty much worthless. The other thing that happens when you bump magnets, a lot of magnets are affected by impact. And not just the speaker moving from the magnetic field, but I'm talking a hard mechanical impact, like, slamming something on the table or, hitting it into concrete. That can actually misalign the molecules inside the metal, and it will deteriorate the magnetic field. Magnets, we call them permanent magnets, but there really is no such thing as a 100% permanent magnet. All magnets will lose energy over time. So, years down the line, they say, about 100 years, you'll lose about 10% of the strength of a magnet. Well, that's not going to happen in our lifetime, obviously, and you'd probably never be able to detect it because it's such a small change. But all magnets will deteriorate over time. But the other thing that's really interesting, the elements have a huge effect on magnetic properties, and the one particular element is temperature. So just like anything, magnets have an operating temperature range. like, liquids, if you go too low in the liquid, it freezes, like water will turn to ice. You get too high of a temperature, it turns into gas. So it changes its properties. What happens with magnets, usually when they get too hot, cold doesn't necessarily have a lot of effect, but when they get too hot, you start to lose the magnetism. And it really depends on what type of material you're using as to when they lose their magnetism. Now, I'm going to pull out some notes here because, like I say, there's a lot of information going on, and I want to make sure I get some of this to you correctly and don't misspeak. So we start talking about ferrite or ceramic magnets. They have an operating range of -60 to 250 degrees Celsius. So that's quite a range. I don't know about you guys, but I sure don't want to be around when it's -60. I was just up in Nebraska last week and the wind chill was almost 40 below. That was bad enough, and that was Fahrenheit. So they have a wide range of use from -60 to 250 degrees Celsius. The Alnico magnets, which once again are used in guitar pickups, they're used in electric motors, they're used in test equipment. They've got a much higher operating range, up to 525 degrees Celsius. So they're really great where high heat applications require a good magnetic field that's strong and consistent. So that's the Alnico magnets. Now we get into regular neodymium, and neo is a very interesting material. It's very powerful. It's anywhere from 10 to 20 times more powerful than the ceramic magnets. So yes, the Power Sport speaker has a smaller magnet than the KS speaker, but it doesn't have to be as large because it's much stronger for its size. But the magnet strength is not the entire picture. The whole magnetic circuit will make a difference, and that's what we'll get into here in just a couple minutes. But when you start talking about neo magnets, something else I didn't realize till I was doing this research, neo is chrome plated. The neo magnets are plated. They have to be plated because they're very corrosive. If they're not plated, they actually corrode and deteriorate very, very quickly. So that's why all neo magnets are coated. They're actually electroplated, chromed, or whatever material they want to put on them to make sure that they don't corrode, something to isolate it from those elements. So regular neo works from -130 degrees Celsius, I don't know about you guys, but that's pretty darn cold, up to 80 degrees Celsius. So we're talking about the ceramic or the ferrite magnets, go up to 250 degrees Celsius. The regular neo magnets operate up to 80 degrees Celsius. And I haven't done those conversions, but if we do pull that up, and if somebody gets a calculator, you can do it really quick. 80 degrees Celsius is a lot different than 250 degrees, so they have a much lower operating range. There's some materials out there that can combine with the neo to give them even higher temperature properties. And when you get to neo, and they've got a grading, if the grade of the neo has a VH/AH, they will operate up to 230 degrees Celsius. But remember, that becomes a very specialized magnet. They get very, very expensive. So while we could use those in speakers, it's not generally good practice because, I know about you guys, but I'm always looking for bang for the buck. And that's one of the things that the engineers, when they design speakers, they've got to balance everything out for, size of magnet, power of magnet, cost of magnet, the ability to produce them. So we use primarily in most of it, our bigger speakers, we use primarily ceramic magnets, which are going to be, they're fairly easy to produce. They're really strong for their size, but not the strongest out there because that's going to be, once again, the neo and the specialized neo magnets. But the ceramic magnets are a very interesting material where basically it takes a lot of heat, a lot of pressure to make the magnets. So we start talking about magnet ring sizes, and you start talking about the Solo X woofer up here, we use a triple stack magnet. Well, why would we use a triple stack magnet? Why don't we just use one magnet that is that thick? The problem is it's very, very difficult and very expensive to produce thicker and thicker magnets. So what we do is we're able to stack multiple layers together to get an added benefit so we can get the same performance but at a much reduced cost. Now, most magnets, the average thickness that you can make a magnet cost effectively is going to be between 20 and 25 millimeters. That's 3/4 of an inch to an inch. That's going to be the maximum range that you can get the ceramic pressed into a good form of magnet. Now, the other question is, well, if that's the case, why don't you use multiple smaller layers of magnets? So once again, we start talking about a 24 millimeter thick magnet, which is about an inch tall. What if I had two 12 millimeter magnets? Now, There are times when you'll see manufacturers do this. They'll stack multiple smaller thickness of magnets in there, and that really has to do with, the cost, the tooling, what they have access to. But generally, speaking, 3/4 to an inch is about the maximum thickness you can get out of a ceramic magnet without going to the extremes of, ultra high heat, ultra high pressure, and, once again, it all comes down in being cost effectiveness. Now, one of the problems when you do stack magnets together, such as you see here, and this speaker uses a triple stack magnet, is between each of those magnets, there's actually a little insulation layer called air in between. They're put together as close together, and sometimes they can be bonded together with glue. In fact, they have to be bonded together with glue. That'll seal up some of the air gaps. But just like anything else, if there's any gap in that material, no matter how small it is, you're going to lose some magnetic energy, or once again, you're going to lose some heat conduction, just like we have, in a backplate and a center pole piece. And that's part of the whole magnetic circuit, and we're going to get a lot more in detail. So the other disadvantage of having a multi-stack magnet is you can have air leaks through the magnet, which do affect the performance of the speakers. So we try to use as thick a magnets as possible without getting too thick that they're not cost effective, and make sure the magnets are bonded together extremely well and they're done airtight. So why would we make a magnet and start stacking layers on top of each other? Well, it really comes down to a couple things. It's not just that, the deeper the magnet, it's better. In fact, the more magnets you stack on top, the more decreasing the return is on magnetism. So yes, putting a second magnet on there is going to give a little bit more, strength in the magnetic field. Putting another one on, it's going to give a little bit less than, what you had by adding the second one. By the time you get to the fourth one, it's almost, just a waste of energy. So why do companies put multi-stack magnets on speakers, versus just one really good, like inch-thick magnet? And a lot of it has to do with cone travel. We want speakers to travel as far as possible. We want to push that speaker to get as much cone movement as possible, to move as much air, to get as much bass as possible. So if this magnet was only an inch thick, as we see here, you wouldn't have a lot of travel, because that voice coil former would actually hit the back plate and stop the speaker from moving. And it's going to sound pretty bad when it does that. So by having multiple stack magnets, I can get more cone travel out of that speaker. Now, one of the other things we can do is we can bump the back plate. You see, we got this nice little curve on the back plate. In fact, some of our speakers, there's actually a dip right around the voice coil, and that's called a bumped back plate, and that gives more cone travel. But there are practical limits to how much you can bump the back plate before it gets really cost ineffective, because forging these huge, metal slugs into back plates and pole pieces takes a lot of energy and a lot of heat and a lot of pressure. Well, one of the things we can do versus having to really force the material into making a really deep bump backplate is we can stack more magnets on there, because that's going to be a lot more cost effective. And let's face it, guys, it just looks cooler with bigger magnets, but it's not necessarily always the case. Don't always assume that the bigger the magnet, the more powerful the speaker. Because even if you use the same type of materials, that may not necessarily be true. And as we talked about, it's the whole surface area of the magnet and the whole way the entire magnetic circuit is built. Just like with car audio, you've got a power wire and a ground wire. You've got a magnetic field that flows through that wire in a loop. You break that loop anywhere, you don't have any more flow of electricity. Same thing with magnets. The most important aspect of magnetic energy is called surface area. Just like the speaker, the cone area, you're trying to push more air, so the more surface area you have, the more output you're going to have. Same thing with magnets, believe it or not. The more surface area on the magnet, the better it couples to the poles, the top plate and the bottom plate, the stronger the magnetic field. So that surface area basically is this area right here and right here. That's where this magnet bonds to the top plate or it bonds to the back plate. So the more contact we have there, the more energy gets focused back into this gap. Now we start talking about the magnetic gap, and this is really the biggest performance factor of any speaker, and that's where the most losses occur. That's because there's an air gap. We know from playing with magnets when we were little, I hope everyone did this, I'm sure I'm not the only one, But you take two magnets and you take like poles, like a north pole and a north pole, or a south pole and south pole, you start pushing them together. The closer they get together, the stronger that force is wants to push them apart. So if you can force these together really, really tight, you get a really strong magnetic field at that gap. The farther they come apart, the weaker it becomes. So that's why when you look at this magnetic circuit, and if we follow the magnetic circuit, basically it goes through the top plate, down through the magnet, through the back plate, up the pole piece, and that is the magnetic circuit. So we break any of those areas and we lose magnetic efficiency. Like I said, if we don't have a good bond, or we got a gap here between the back plate and the magnet, or a gap between the top plate and the magnet, you're going to lose some of that magnetic energy. But more importantly, you have something called the gap. And here, you start looking at teal small parameters, you look at the width of the gap, the height of the gap. All of those have a really, really huge influence on how much a speaker can move and how much strength it has. Now, magnets are measured in something called BL. It's like horsepower. So the higher the BL, the stronger the magnet. And to get a higher BL out of a magnetic circuit, you want this gap as close together as possible. The problem is you have a voice coil that's moving up and down inside that gap, and it's a lot longer than the gap, so if it gets twisted sideways, it can rub. And if you guys have ever heard a speaker rub, that's that scratchy noise you hear when you start playing, lower frequencies, or even a upper frequency in a mid-range. If it starts getting really scratchy, nasty sounding, that's because that voice coil is rubbing on the top plate, or it's running on the pole piece itself, causing noise. So this gap right here is very important. If we make it too small, we're going to have great magnetic performance, but you've got a speaker that's very susceptible to causing noise and actually scraping through the windings of the voice coil and burning up. And if you make it too big, the speaker doesn't become as powerful. You don't have as much BL because the gap is much wider. So that's why this gap is probably the most important next to the surface area of the speaker in controlling the power that the speaker has, and once again, the performance and how much push it has both in and out. So it's really kind of interesting. Same thing with the voice coil. We can put multiple layers in the voice coil, but multiple layers is going to make that gap have to be bigger. So that's the key with making speakers, is you want as many windings as possible, as much copper in as possible, but as thin as possible. So there always is a trade-off. You get to a certain point where more windings is going to allow the speaker to, handle more power, but you get the problem that the gap gets too big, it's too inefficient. Same thing happens when you start talking about the diameter of the voice coil. Not only with speakers, you talk about the bigger the magnet, the better. Well, same thing with voice coils. A bigger voice coil is not necessarily any better. The problem with a bigger voice coil is we're going to spread that area apart. We get less surface area with the top plate and the back pole piece and back plate. So you lose that magnetic energy because you have such a big diameter voice coil. And on the other side of that, the bigger diameter voice coil gets heavier. So it takes more power to get it moving. So you get to a point where there's diminishing returns, and the point where you actually start going backwards by putting a larger voice coil in speakers, especially if you're looking for long travel. So like I say, there's so many different aspects to magnetism and the types of materials and how they work, but they all have to be designed to work together. And same thing, you look at this pole piece on this speaker, you've got your top plate here, and then you've got the pole piece, and this is called an extended pole piece. That means it extends above that top plate, and this one extends, almost 1 3/4 inches. What that'll do for us with that magnetic field, as it comes through this wire, that magnetic field is developed around the wire. By having an extended pole piece, that magnetic field will travel in these two directions, and it will be almost equal on the top and the bottom of that top plate. If this voice coil and that center pole piece stopped at the top plate, above the top plate, that magnetic field would be allowed to spread apart, weakening the magnetic field where it's very close down here, very tight. The speaker would have a stronger inward pull than an outward push. So that's what I mean when I say it's very important to have the proper design of a speaker. It's not just all about putting the biggest magnet you can put on it, the biggest voice coil. There definitely becomes a point where those are going to work against you in the long run. So When you start designing speakers, and once again, I'm not an engineer, and we've got some absolutely incredible acoustic engineers back there that design these speakers. We take a lot of pride in how we design the speakers here at Kicker and what we do. We design every speaker right here in-house. We own the tooling to make all these speakers. It's not just a bunch of parts thrown together like some of these companies do. They'll go by, hey, I want this basket, I want that back plate, I want this magnet, I want the cone to look like this, and put them all together and they hope it works. Well, generally it's going to work unless they really screw something up. But it depends on how well it's going to work. It's just like an engine in a car. Everything has to be tuned right. You know, if you take a car and you got a perfectly tuned engine and you decide, hey, I want more power, so I'm going to go out and I'm going to get a bigger carburetor and put on it so I can get more fuel into that engine, it's going to be more powerful. It may or may not work. You may get a little bit of improvement, but chances are you're going to imbalance that entire system and you're going to sacrifice performance, which is the next thing that, you know, is really interesting about magnets on speakers. People ask, can you have too much magnet on a speaker? You really can. Not only can you put so much magnet on a speaker, it's really expensive and not cost effective to produce, but when you over damp a speaker, when you put too much magnet on it, you control the cone too much, you will actually lose output. And I know that sounds absolutely backwards. The bigger of the magnet you put on a subwoofer, the less output you get because it actually dampens the speaker. It changes the electrical properties, it changes the balance of the speaker, and you will actually get less output from a speaker by putting a bigger magnet on it, especially when you get into the low frequencies. Now, some of the other things that happen with magnets and low frequencies and, you know, changing the magnet structure, you'll see some people that'll take, you know, say a speaker like this and they'll put a magnetic ring on the back of it. What they're saying, well, hey, you know, I'm trying to increase the magnetic performance of that speaker to make it better. Well, what you're really doing, one thing is you're wasting your money and your time because, especially with you know, Kicker speakers and most companies that design their own speakers, this is already a balanced circuit. It's going to be as good as it can get for the money, and just adding something to it is not going to improve it. But if you put a magnet on the back that, you know, matches up with the polarity of the magnet we have on the speaker already, it's not going to really give you any benefit because what we want, that magnetic energy, is going to flow from the back plate through the magnet, through the top plate, through the pole piece and back. If I stick another magnet on the back of that, it's not part of the magnetic circuit. It does not really affect the performance of the speaker unless it becomes so great it actually changes the magnetic properties, actually pushes the magnetic field because it's so strong away from the gap that we have in the speaker to begin with. Now, people are asking, well, what about magnetically shielded speakers? Well, that's what they call a bucking magnet. So what we'll do is we'll take another magnet, similar to this one in size and strength, and we're going to invert it and put it on the back of the speaker. And what that's going to do for us is that's going to help contain that magnetic field from escaping into the atmosphere. And that's the other thing that speakers, you know, run into a lot is, you know, the efficiency, the losses. As that magnetic energy escapes or goes into other mediums, we start losing magnetic energy. So just putting a magnet on the back of the speaker is not going to aid the performance. In fact, it can only really harm it if it's done really poorly. But when you magnetically shield a speaker, you flip another magnet upside down, those two forces cancel each other out. It's like having two speakers out of polarity. And if you want to further that cancellation, that magnetic field, which they really need because compasses are magnetic, especially in marine. And in the old days when we had CRT tubes, you guys probably don't even remember the tube TVs. That was done with magnets. You put a magnet too close to the TV, it changes all the colors, and sometimes it goes back and sometimes it doesn't. But the same thing happens with the speaker. You put that bucking magnet on, you put a metal cover on it, and that really contains that magnetic energy, so you can put that right up to that TV screen and it won't affect it. And those are called magnetically shielded speakers, which are especially important, once again, in marine and with the old CRT tubes. Especially important with marine because compasses work off magnetic energy. And if you've got a speaker too close to the compass of the boat, it's going to draw that to it. Now, the nice thing is with GPS and a lot of the modern technology, they're not so much always based on magnetic technology, but they're also done a lot with, you know, with Wi-Fi and GPS and that type of global positioning. So a lot of interesting things on magnets, and a lot of, bizarre stuff to learn. And I love I'm still laughing about the old point before where it's like, the magnets, that was the thing this other vendor's like, we don't put boots on our magnets because they get red hot. Well, this is a ceramic material. It'll get warm, but it's never going to get red hot. And think about it. What would it take to make something this big red hot? Do you think you got enough energy going through a little voice coil to generate that much energy that you get that magnet red hot? Yeah, probably not. And if you could, that would be actually pretty scary. So magnets are, absolutely crucial for speakers, but there's right ways and wrong ways to do the magnets. So the biggest keys are the magnetic gap that we have right here where the voice coil is, and the surface area amount that we have between the top plate and the magnet and the back plate and the magnet. So as a recap, the smaller the gap, the stronger the magnetic force, and you can get by with a smaller magnet for the same amount of power. But if I have a really, really big magnet, really powerful magnet, but I've got a very large gap where the voice coil is centered, we lose the strength of that magnet, so it kind of defeats the purpose. So it's all about designing a speaker that's balanced. So let's see what kind of questions we got coming up here. And I guys promise you, I may not be able to answer all the questions because I am not the magnetic engineer, but Bill will make sure he records all your questions, and we will get an answer to you, even if we have to make it up. No, I'm just kidding. We won't make it up. That wouldn't be nice. But hey, I might learn a lot by your questions just doing a little research. So absolutely. Let's see what we have for questions. JW, what do we have? 25 Hertz to Life. Welcome, guys. I appreciate you guys tuning in. We've got a lot of the regulars out there. And, while we're on this subject, before we get into the question, don't forget to tune in for Living Loud with Andy tonight. And I think we're up to 39,000 people in the Kicker Club. That is awesome. Thank you guys for all your support. And Andy will also be doing his show on Friday night. So thank you guys for your support, for us, and thank you guys for supporting Andy as well. He does a great job out there, and his shows are a lot of fun too. And in fact, I've been a guest on his show a couple times, and I enjoy it. It's actually kind of fun. I actually had more fun than standing up here doing it all on my own. It's kind of nice to have somebody else to bounce stuff off of. I just got Steven back behind the camera up here making faces at me, trying to get me to screw up, which doesn't take a lot these days. I get very easily distracted.
Move that bottle behind the sub.
Do what? See?
Move that water bottle behind the sub.
He wants the water bottle behind the sub. See, it looks better already. See, I told you he's always trying to mess me up here. All right, 25 Hertz to Life asks, question, do different types of magnet create heat, thus requiring the boots to be taken off? No, magnets are insulators. They, especially ceramic and ferrite magnets, they do not create heat. Magnets can get warm. Where you really get heat buildup in speakers is actually the pole piece, the back plate, and the top plate, because that magnetic flow through that metal have what they call magnetic eddy currents. Now, the magnetic currents flowing through metal do create heat, but if you design the speaker properly, once again, a really, really thick top plate's got a lot of metal. It actually has a lot of magnetic eddy currents. It can actually create that way. So having too thick of a top plate does create heat, but it's the top plate, not the magnet. So I don't know if you guys have ever seen, there's a technology out there that they use in auto mechanics in construction. If they've got a really rusty bolt and they want to free that, they've got to heat it up. You've seen people use torches to heat up bolts. Now what they've got are some great little devices that basically are a big AC transformer that's alternating current and a coil of wire, like 2 or 3 coils. And what they'll do is they'll put that coil of wire over that bolt, plug it in, and that magnetic energy will create currents inside the metal from the magnetic energy changing directions called eddy currents. And that moving magnetic energy, just like anything, you run a lot of power through a wire, the wire gets hot. Same thing happens with the steel. Now, it's not, in a flow, but the magnetic eddy currents are causing the electrons to move inside the metal, which they, once again, create friction, create heat. That's how they heat up that material without applying, a flame to it. I saw a really cool video. I like to watch how things are made. And this company was making chains, like, I don't know if they're not necessarily bike chains, but, like for anchors or, towing chains. But they would literally take this chain from the raw molded metal and they would run it through this coil, which was a magnetic field, and the chain would go into that coil cold. It would come out the bottom red hot. It actually produces that much heat by running that energy through that magnetic coil. And then they actually dipped it in oil to cool it, and that actually gives it its strengthening. That's how they temper the metal to make it stronger. So it's really interesting, how the currents in the metal actually create heat. And you get the same thing, in center pole pieces. If you've got too strong a magnetic field, you can create problems with the pole piece. Generally, we don't use a really, really large pole piece. Once again, it's all in that balance from voice coil diameter to the gap to the diameter of the pole piece, the height of the pole piece. Is the pole piece connected to the back plate? Is it stamped together? Is it pressed together? Because if they're not one material, you lose magnetic energy and you also lose heat transfer. That's why one of the things that Steve pioneered years and years ago was what we call the uniplate, which is where that center pole piece and that back plate were one solid piece of material that gave us a much stronger magnetic field, and it gave it much better cooling because the heat that's generated in that pole piece is then directed to the back plate, and that is the radiator for the speaker. So great question. Magnets don't create heat. They do get warm because they are attached to the metal that does get warm, and they're also in close proximity to the voice coil. The voice coil is really the point at which all the heat is generated. That's the point where it starts, and it gets dissipated from there. The better you can dissipate that heat, the more power the speaker is going to handle. And of course, we just keep bouncing around. There's so many different ways to go with magnets. And the big question is, all right, so if we just go ahead, make a magnet bigger, make the center pole piece bigger, it's going to be a much better speaker. And the answer is no. It's all about that entire circuit. Can I make a magnet stronger by just sticking another one on the back? No, it doesn't work that way. It's outside that magnetic field. It can actually harm the output, but it can do some good things, and that's magnetic shielding. So just a quick little recap. So what other kinds of cool questions do we have we can rumble through here tonight? And once again, if you guys have not registered, it's 8:10 right now. We're already past the cutoff point. So if you miss registering for the giveaways for tonight's show, tune in 2 weeks and you can register again, because we do those giveaways every single show we do. And also sometimes we give a lot cooler stuff too, like entire systems and a few other things here and there. So Clint Black, are you the singer Clint Black? If you are, good job. Appreciate the music. If not, you got a great name. Run with it. Just pretend you are. All right. Do smaller magnets run hotter than larger magnets? No. Once again, the size of the magnet does not matter. The strength of the magnet does not matter. It's all about the magnetic circuit and how it's designed. So magnets don't produce any heat. They do get warm from convection by being close to the metal that does, but they're not going to cause the speaker to get much hotter. So next question, Mr. JW. And Bill, I appreciate you tagging in back there. I know he's trying to answer things as fast as he can as well. So if we don't get to your questions, rest assured, we'll get to them at some point and get back to you. And once again, it's social@kicker.com or support@kicker.com. They go to 2 different places. Support goes to the technical guys, social goes to Bill and us back here. So that's the differences in the 2 email address. Brian Park asks, what about those old pyramid subs with signal magnet layer, but it was super wide? That's a great question, because that's one of the things that I've got sitting right here in front of me. And it depends on what they're trying to do. Here again, it's not necessarily the width of the magnet, but it's that surface area they get on the top and the bottom where they bond to the top plate and the bottom plate. When you look at our ST series speakers, that has got a pretty big magnet. I mean, it's quite massive for its size. Well, why would we do that? Why did we put such a big magnet on here? Was it to make it look cooler? Well, yeah, it does look cool, but that's not necessarily the most important reason why we did that. These speakers were designed to handle extreme amounts of power. Most of the speakers, these high efficiency speakers, they have a pretty small voice coil, because you want to have efficiency, you have to take weight away from a speaker. Well, if we want more power handling, we have to get more copper in the gap, so we have to have a bigger voice coil. But when you put a bigger voice coil in the speaker, now you got the problem with it becomes less efficient because it's heavier. There's more mass in the gap. So you need a stronger magnetic field. And how do you do that? It reduces the surface area. That means making this magnet bigger in diameter. So it's got a larger opening in the center because it's got a much larger voice coil. But we make up for that by putting a larger diameter magnet on and keeping that surface area and keep that magnetic field energized. So why don't we just put bigger magnets on, the speakers that have a small diameter voice coil? It just doesn't have as much effect. You get to a certain point of saturation, you can't get any more energy into the gap. And that's why it's very important to design the entire speaker properly. It's really interesting. interesting, reading some of the formulas and the theories and some of the things that are going on out there. So I absolutely found it very fascinating, and there's going to be a lot more articles I'm going to read because I want to know more, because it really is cool how speakers are made. You just put a voice coil on the speaker, put a magnet on it, put a cone on it, sound, and you're done. That's not necessarily the case. Now, they're playing with my screen up here. I'm not sure exactly what they're doing. What are you doing back there? They're ignoring me. StreamYard's acting up. If you guys are having StreamYard issues, that's because, and he says it's back up. I think they just cut me off on purpose. Well, I can't blame them for that. So, yeah. So, another interesting aspect about speakers, we start talking about that magnetic energy, just like anything else. If you put something on the magnetic circuit, say, on the top plate or the bottom plate, that actually has magnetic properties, like a ferrous type material like metal, it can actually pull energy away from the gap. Now, what do we mean by that? Start talking about the Solo X woofer up here. This uses a cast aluminum basket. Aluminum does a couple things. People say, oh, you got a cast aluminum basket, that's better because it's stronger. Well, it's not necessarily stronger than steel. So again, it depends on how it was designed. Well, you use a cast aluminum because it looks cool. Yeah, it does actually look kind of cool too. But believe it or not, the material can actually add up to a dB more sensitivity or dB more output to the speaker. Sensitivity is how loud it plays with how loud it plays with very, very efficient, very, very efficient. With the smallest gap as possible and enough surface area to keep that whole magnetic loop in check. Well, if I take a stamped steel or a cast iron basket and bolt it to that top plate is directly related to the magnetic circuit.